Boom.
Hey everybody, welcome back to the Unreal Engine training stream. I'm your host, Alexander Pascal, and joining me today, Mieszko.
Perfect.
Ah!
Yes.
Yes.
Hello,
Yeah.
everybody.
I didn't pronounce it Mieszko or any of the other ways.
Stop.
that
Stop.
drive him crazy.
To the point.
All right.
We haven't got all day.
Yeah. So
Let's
straight
do
to the
AI
point, we're going to be
stuff.
doing an AI stuff stream, a getting started with AI in UE4 stream right here, right now. First, I want to go over just a very high level how AI stuff works. Can we just jump to the main screen real fast, Clint? And I'll talk about this. Now, Frank Tech actually sent a couple of interesting links, one of which was about adaptive and learning AI strategy and stuff like that. It's a little advanced for what we're getting into today, but I did want to bring up this other one. The color on it isn't super awesome because it's kind of pink on like with black text, which is a little odd to look at, but I assure you it's actually great information here. But askgamedev.tumblr.com has a post about game development myths. Players want smart artificial intelligence. Actually, a lot of questions I got were, how do I make really intelligent AI? I want to make my AI like super smart. And Mieszko,
Wait, that's actually a key, what you said. I want my AI to look super smart.
To look super smart.
That's the point, to make it look like it's smart and believable and stuff like that, not to actually be super smart. Because that's not fun being destroyed by smart AI all the time.
Yeah, now I'm not going to go over the entire article, but I did want to show off these 3 images because they totally wrap up what the article is getting at very quickly. First image, you can see a player, 3 AI bad guys that have cover, firing from cover. This is a pretty easy to understand scenario in a lot of games, shooter games, I don't know, like Uncharted or anything like that, where you have guy hiding, multiple enemies coming at you. Now, intelligent AI, really intelligent AI, would keep one of them around to distract you and send the other guys around to ruin your day. That's not fun. And actually, The Last of Us is actually a good example of this. Have you ever seen The Last of Us? They have a few great articles about how the AI was originally super smart, and they had to dumb it down because it's not fun, but they still create the illusion of it being smart. It just, it doesn't actually go through with like the full flanking. Instead, they kind of get around to this point and start panicking. And they don't go all the way around to mess with you sometimes. And yeah, the big one here is players hated it. So today we're going to talk about designing AI to work just for what your game needs it to do, and how to pass some information around using a couple of AI guys in the world. But this is a great article, really goes into great details to why you don't want to make everyone as smart as a sim, basically, like from like The Sims. It's like there's too much going on. Like they don't need to worry about how hungry and tired and happy and depressed they are. And
well, actually,
a whole
AI
bunch
in
of other
Sims
stuff too.
is extremely simple.
Incredibly simple. It's basically a series of float values that they just base all their judgments off of, and that's mostly it.
And there's plenty of stuff in the environment that...
And actually, what we're going to be setting up today, you can use as generic usable items in your world. So I guess technically you could build off of this to make a Sims-like game. So I'm going to hop right into it and get making the first few things here. So once again, thanks Frank Tech, really great. Make a new project. First thing, we are in 4.14.3 for this, but you can be in just about any version for this. We're going to be using stuff that's been around for a very long time, so don't have to worry too much about that. I'm going to call this one Basic AI just call it Basic AI. And that's going to be it. Create project. Now, what I used here was a basic top-down template to create the project out of. I'm sorry, the little indicator went onto the left side of the screen, so we have nothing to show you as it opens up the project. But the project's opening over here, and it's open, and I'm moving it. There we go. So this is the basic top-down template project. You can see that it comes preloaded with a little character in here, and we're going to use him. But really, we can use just about, basically any of the projects that have a character in them, a character type, character class derived blueprint of any given type. That just allows them to move around the world and do stuff. So in this instance, we actually have a lot of stuff pre-built for us, so I'm going to explain what's already made. First, if you're following along, hit the P key. That's going to actually be a hotkey for P. What? It's nav mesh.
Yeah,
I'm just showing them the nav mesh.
Why it's so ugly, because I've changed the default nav mesh color like over a year ago, but every sample still has this old color, which is
Okay,
It's just
it's a color
ugly.
Mieszko doesn't like. But
By the way, you can always change the color of navmesh being drawn in the navmesh in the project settings, navigation system, supported agents,
Okay.
where you define your custom navmesh parameters, and you can define the color for it as well. Please change. Don't use this ugly green.
he doesn't like the green. Okay. We'll go
It's an
into the
ugly green.
project. Okay, you want me to show them how to do that here? Just where was it again?
Project settings.
Yeah, project settings.
Project
Okay,
settings.
whoops. Sorry, edit project settings.
Yeah.
And then I'm going to open up project settings.
Navigation system on the left somewhere.
Navigation system.
There's the support agents array.
Support agents.
Add
Okay.
an entry there.
Uh-huh.
Here you can specify the
Oh, okay.
parameters for navmesh generation.
Yeah, I'm going to make this kind of like a happy
Well, not
blue.
navmesh generation, the agent, so radius, height, and stuff like that.
Okay, okay.
And we can use a different color.
Cool. So
it's-
is this good? That's cool?
It's better.
Would that work?
Yes.
All right. So if I go in here and I press P again, well,
You
it's
would
still
need
green.
to rebuild it or reopen.
Okay, I'm not going to do that.
Just reopen the map.
No, I'm...
Save it, then reopen it.
So I had this whole thing, like there's actually like a point by point what to do, and now he's over here telling me, now let's
You-
go off script really quick.
You bring me here just to have excuse
So-
to go off script.
Save. So I saved the level. You want me to reopen the level is what you're saying.
Off script is my middle name. Mieszko off script Zilenski.
Zilinski?
Zieliński.
Zilinski?
No, don't. You spent like 2 years learning Mieszko and
There,
now Zieliński.
look, it's beautiful. Okay, it's blue. I'm so sorry. I'm so sorry. We got it now. It's
Okay.
blue. It's happy. Everybody's happy.
Adrem.
It's a beautiful blue color. I'm getting back on script now.
It's not blue, it's velvet.
I will. Cool.
Carry on.
Ah, okay. All right. So.
Keep calm and carry on. And make things.
so all right, enough goofiness. So we've got the level changed. We went into the project settings. We changed some colors there. That wasn't actually something I was initially going to show you, but what's
But
important...
Mieszko is here.
But Mieszko is
and
here.
his middle name is off
Yes.
script.
But what I want to show you is the reason that we have this pre-built nav mesh, this thing that we're seeing that's overlaying the ground, is because we have a nav mesh bounds volume already in the level. What this does is everything encompassed within the nav mesh bounds volume will that has a flat Z up surface. Basically, it tries to draw
Flat-ish.
this ish,
Flat-ish, yeah.
flat-ish. Yeah, flat. There's a certain amount of
Walkable.
angling to it that you can get to before it starts cutting off, and we'll get into some of that maybe later. But point being, this is the thing that your AIs are going to be using to determine what it can actually move to. So when we find points to move to, it's going to use this nav mesh, this flat plane that it's generated to figure out what it can actually go to. So on here, I'm just going to show real fast. We can go to the world outliner in the top right, and I can just type in nav mesh, and then we get nav mesh bounds volume. So on here, you can actually see it's literally a box, and that's it, just this box. And I can delete it, add a new one, and show you just exactly how that works. Nav mesh, whoopsie daisy. If I go to volumes, actually, that would help. So over in your modes, go to your place mode, volumes, and you can just type in nav mesh. Once a space, that's why I was doing it all as one word. And put that a little bit into your ground, and you'll see immediately it's pulling out a new mesh. And we can just straight up go to the scale tool and scale that to the size of the playfield. The end. Same thing.
Yay.
It works the same as the one that already existed. We don't have to do any kind of setup. It's pretty much set it and forget it, which is really helpful. There's a lot of other settings for like if you want it to not spawn on the top of these objects, but you do want it to encompass that. But those are set per mesh, and it's just a checkbox in here, right? Because that's the...
There's a couple of ways to do that.
Oh, okay. Well, normally I just use the checkbox in here for widget navigation, and no, it's not that one. Which is the checkbox in here?
So you can mark a mesh to not influence navigation at all,
Yes.
but that also means it won't cut holes in the nav mesh.
Oh, that's true.
The other way is in the static mesh editor to define
Mm-hmm.
a thing as being a navigation obstacle,
Yep.
and then it doesn't. That it
Is
just marks.
dynamic obstacle.
Yeah, it just marks up the navigation underneath, but it cannot
You can't get
generate,
on top of it.
Yeah,
Yeah.
and you can specify different area types for the area that it generates on NavMesh. So you can have a null area which is unwalkable, but you can have your custom areas like crouching or sliding, and this is the place you would set those.
Yep. So it's like you said, just here, details of the static mesh. Type in. I just typed in OB for obstacle and immedially popped up. But is dynamic obstacle?
The navigation section is at the end of static mesh properties. But there's a couple of things you can set up there.
Exactly. There's a few different things we can set up, but that one's just really good for practically like just getting rid of nav mesh that's on things you don't want it on, which happens a lot in scenes. So so that's the gist of what's going to get us around the world. Let me go ahead and start making a couple things. First, I promised that this one was going to be about two AIs interacting with each other. So let's just build something that's not actually AI, but we're going to just build a quick little animation. I know it's not your world and all that, but
yeah, I'll just have an app.
You just chill for a second, and it's going to be fine. But I'm going to open up an animation, and I'm going to make a quick animation for use, like the generic idea of using, where he's just going to put his hand forward and then pull back, and that's it. So it just looks like he's doing something. So I'm opening up third-person idle, which is just under the animation folder here. In third-person idle, I'm going to grab this little slider down at the bottom, which is the animation slider. I'm not going to get into a ton of details as to how, what, where, and why you're going to want to set this up, because I'm basically just making an asset live to show you how it's done. I select a bone that I want to alter. In this case, it's upper arm R, which is the right upper arm. I'm going to press S to keyframe, and that generated a keyframe at frame 0. I'm going to drag all the way to the last frame, and I'm going to press S to keyframe it again. And so now I have two keyframes that are in their default position, and somewhere in the middle here, that's where I'm going to rotate it out, and press S again. And then we should get this smooth little kind of reach out and grab an animation. So we just made a quick animation in the engine instead of having to go out into something and make it.
It's like magic.
Yeah, it's like magic. Thank you so much, Lena, by the way. Lena Halper came over and showed me what I was doing wrong, that this wasn't working. And she's great. This whole system for creating animations is really fun. Next, go over to Create Asset, because we're done making those keyframes. And then do Create Animation from Current Animation. Boop. And I'm going to put this in the animations folder, and I'm going to rename it top down use. Okay, cool. Now idle's still going to show that it has that alteration we put in it if we do that, but actually it hasn't. So when we actually use it later, it'll be fine. We're not going to save the alteration we made. Instead, we're just going to kind of skip over that. And instead, I'm going to save my use basic guy here. Save. And now, one last thing, we actually don't need a full animation. What we need is a montage. So right click on that new use animation we just created and create an anim montage. And that's it. So this one's just called top down use underscore montage. I'm going to keep the default name. That works. Why not?
It's just a name.
It's just a name. Now I'm going to show you this real fast. I open it up. You can see he does the montage and then goes into an A pose. But point is the montage works. And its default group is default grouped here. This is something where you're going to probably want to look at some animation streams to see more about animation and why that works. But I'm just going to quickly jump into the blueprint and inject this animation so we can call it up later. So what I've built here is this use animation, but we now need a way of saying to the character that we can kind of cut through whatever animation we're already doing and add a little like arm up animation montage. So I'm just going to add in a slot. Whoops. Helps if I spell that right. Slot. Which we need to drag off of the state machine to do. Almost forgot. We're going to add in the default group slot, which is just what we kind of made there. All right. Now we have the ability to make that use animation montage happen on command, which is really important for when you want your AI to actually show what he's doing and not just blindly transferring numbers that you can't actually see happening. Cool. So that's the animation that we've made and put it into our AnimBP. Next up, let's actually start building some functionality for the AI to work with. what you're going to want to do is build a little packet of, I guess it's what I'm calling it, is like a packet of functions that you can inject into anything that is usable. Because that's what this one's all about, is AI using things. So let's make an interface and call it is usable interface.
It doesn't sound like an interface name. Is usable is like a name of a function on an interface. It's like usable usable thing interface.
Okay.
I know it's just a name, but things should be named
Usable thing
correctly.
Interface.
Yes,
It
it's-
is. Okay, usable thing interface.
Perfect.
Okay. Thanks.
Well, as long as you were
It's good.
talking about animation, I didn't care, but now
Now it's back in
now I
your
care.
realm and it's all about it. So we're going to open up that interface. Inside it's going to have one default function that has nothing built onto it. So the first one we're going to make here is used. So when something gets used, what should happen? This is a function that's going to be pretty basic since we're going to tell each individual item what using it means. A treasure chest being used should open. A person being used should, I don't know, transfer information. An ice cream cone being used should be eaten. So whatever we are, we get used. And the first thing we want is the using actor. So I'm gonna pass that along. In here, I'm gonna make this an actor actor reference. So what we can do is when we call the used function, we can say who's doing the using. So the thing being used can then in turn say, actually, no, that thing can't use me, or now I have that information and I can in turn turn it into something else. Now, for the sake of this tutorial, I'm going to add in one more variable to its input called called value, which is an integer. Value is going to represent any kind of data that we want to pass from one AI to another, and that's it. So it can be anything. It doesn't have to be an integer. It can be floats and vectors and other actors, etc. But for the sake of this, we're basically going to pass coins or something, some sort of a resource value. Next thing we want is a can use function. So can use will be a function that we call when we want to actually figure out whether or not something has blocked us from usability. A treasure chest that's already been opened should probably have a variable in it that says, I've been opened, don't bother with me, there's nothing in here, so don't bother. So in here we're going to put an output. The output is going to be of a Boolean value because what we want to know is simply, can it be used? Yes or no. Is usable. And that's it. So when we call this, it's going to reach into the thing that we're using and say, hey, you, can I actually use you? And that'll be that. And finally, the last function that we're going to need.
Wait.
What?
So if you have a function can use,
Yeah.
shouldn't you pass a parameter in who's asking the question?
I could very well do that. Like for the inputs here, we could do yet another actor. Actor, actor reference. And so we could say, again, we could get the user information if we wanted to, using actor. Cool. So yeah, if we need that info for whatever reason, now we can pass that along too. And I'll show you how we pass that information through in just a minute when we make a task that activates these functions. But first we have to build the functions to activate. The last function we're going to make on here is use object. This is the function. So this interface is actually not just for something that can be used, but also for things that do use other things. Sort of a kind of strange concept, but you are capable of being used and also using something else. So we want to be able to have both of those called as two separate concepts. So
Well, usually you would have two separate interfaces for that, but for
we could.
Yeah, for
We could.
simplicity, say.
But I'm
let's just
assuming
have one.
that any of your AI should be usable and also can use. But yes, he's right. This could be two separate interfaces so that only certain things have the ability to use and can't be used themselves, and others can be the other way around. For the sake of this, I'm putting them all together. It doesn't hurt too much of anything. I don't think that we're going to see
No,
any kind of
Harmless simplification.
Yeah, it's just one simplification. Like you said, harmless, mostly harmless. As far as I know, it has no harm, but I'm just going to say mostly harmless for safety's sake. And then, yeah, so the only thing that this one needs to put out is used object. So when I, as an AI, use something, what was that thing I used? And does it affect how I am doing stuff now? Because I've used it. And so the used item can, in turn, transfer back up to me. So that's what that is there for. We could also put value and some other things on this, but like I said, it's only the information you need to transfer. So that is our interface. It's those three functions, and now we're going to put it to use. I'm going to save it. All right, so let's open up top-down character. You could make a separate AI character derived from this, or a whole new character, but frankly, we don't need to. We can actually use the same exact character that we're moving around in as also the AI character, as long as we make a couple adjustments and tell it to use AI instead of player input. So you'll notice also in here when you open it up, there's quite a bit pre-built. But this up here, that up there up top is just for VR HMD stuff and isn't really important, but I'm going to ignore it for now because it's not hurting anything. So first things first, let's go into our viewport actually, and let's add in, he's doing this instead of the idle, of course, because that's just my luck. Hang on a second. Mannequin, animation, and hopefully I didn't save over the idle. Cool, so what I'll do is I'll just make it stop doing that, just to be super safe, by grabbing the upper arm and doing reset bone transform, and there's remove frames or whatever, but that's about it. All right, it's gonna fight me today, but whatever. Which is weird because I did that earlier. Totally fine.
Sure.
Yeah, sure, Alex, sure. So if I go in here, I actually wonder if I go in here and I hit play real fast. Yep, there he goes. He's doing it too much. That's not good. No bueno. I must have done something funky that I did slightly different, but I'll just keep going. Next up, we're gonna insert.
Now it's too late to undo it.
Yeah, now it's too late. Yeah, probably. I'm sure Lena's like watching this, like, Alex, come on. So we're gonna insert a text component that will be our text render component, and this will be our value display. Pow. So now we've got our value display going. That's going to drive me crazy, is the guy just constantly wiggling. So under our value display, we can use this to change the text number that's on it. We're also going to want to bring this up. Sorry, I meant to stay in this view. So we rotate this back so we can actually see it a little bit better. And I'm going to change the horizontal alignment to center, and I'm going to change the text to just be the number 0. And this will represent whether or not it has information. So by default, no information. Okay, now the blueprint interface that we made before can be injected into any blueprint that we made by going up to class settings, going over to interfaces, and then down here we've got, what did you make me name it?
Look for interface.
Usable. Well, they all say interface at the end. That doesn't help. Usable thing interface. There we go. Usable thing interface. Now, I don't know if you noticed that, but the second it went in, can use showed up in the interfaces. And we actually got the two other functions as events. So let's go ahead and set everything here up. All right. We're also going to want, we're also going to want to add in a Boolean value under variables called isUsable. And I'm going to expose that one, compile, and just leave it as is for right now. But that'll be the variable we check against later using the canUse function. And in fact, we can set that up first. So open up canUse by double-clicking it, and we can see here that this is all that it is. So when someone calls this, what they want to know is the status of the isUsable Boolean. And that's just it. So this can represent, like I said, treasure chest is open, do not bother trying to open it again. And next up we have the use object event. So we have a add event. See, there's calling it and whatnot. We're not calling it. We're actually setting what it does within the character. We want to say inside of this event, when we use an object, what happens, versus in this one, used, event used, which is when we get used, what happens. Now, there is a value here going in, so we should probably give ourselves a value as well. So I'm just going to go ahead and promote that to a variable and call this one value. So when we get a new variable put in, a new value put in, we'll want to add it to whatever our previous value was. So like if we're passing gold coins around, right, we want to say, find out how many gold coins you have, give them one more gold coin. And that'll be what the use event does. Once we do that, let's also set this to false. So once we get used, we shouldn't be usable again. Whatever this value represents, we do it, don't let them use it again. And then we can find ways to set this so we can be reused. So from that, we also want to take that text render that we did before, that value display, and we're going to set text on it. So when we get used, we update how much our value is worth, and then we take that value, and this is really cool. Just going to click it over here, and it does int to text, and we're going to display that value when it updates. And you can actually make a couple of adjustments here, such as like basically you can clamp the minimum and maximum of the digits, but that's about that. So we're just going to set it like this. As we get new information pulled in, we will update the little icon above our heads to say, yes, we got it. Next up, for the event used, we're going to do a do once. Now this is how we set up a montage play here, is do once, do once, and we're going to play montage. So this is that montage we set up before, and if I can actually reset it so it's just idling like normal, we won't have that problem anymore. But we changed the montage type to the use montage we made before. So when we are called to use an object, we know we're supposed to play an animation. Now your return value is how much time you have until the animation is finished. So we're going to throw a delay on that says we can't trigger this again until it has gone through and finished the animation. So we won't end up with like a weird jittery animation if he tries to use something over and over again and just look kind of strange. So those are what our two functions are going to look like within the character for transferring information and knowing when you should actually reach out and use the event. All right, next up, we're going to create a Blackboard for the character. You keep
actual AI stuff.
Yeah, you keep looking back and forth at me. It's making me nervous.
Yeah, I can just
all right. Thanks. Yeah, you look over there. That's
okay.
right.
Let me know when you feel comfortable enough so that I can look back at you.
I'm gonna make a folder for AI.
Can I peek?
Yeah. You can look.
I'm kidding.
So
just don't worry.
I'm gonna make a. You know that the animation thing's gonna drive me crazy. I'm gonna just take 1 second to.
If you haven't saved it, you can restart the editor. And it should, because you haven't saved the changes.
Yeah.
Which could end up saving us time, because now you're gonna have to look at it and try to figure it out.
Why you gotta be?
And
like
you have
that?
no idea what you're doing, so it can take.
Wow! The confidence.
I'm kidding.
The confidence.
AI is actually the only thing I know more.
No, can't re-import.
About than all the rest is. I've actually learned you can do this animation stuff because I'm not working with animation.
Okay. So just doing that stuff. Okay.
Yeah, and I'm teasing you as well. So.
Okay. Well. So I'm gonna just come back to that then, since you're just gonna make fun of me if I try to do anything there. Where was I? Now that Got myself all off track. Oh, right. Blackboard and behavior tree. So I've made a new AI folder. In the AI folder, let's build the two main components of any AI in UE4, which is your Blackboard and your behavior tree. A Blackboard is essentially a struct of variables that you're passing into your behavior tree, and you can alter from tasks and your character, the environment, etc. So let's go ahead and make a Blackboard. Any recommendations for naming?
BB underscore whatever. BB underscore something. Yeah.
Okay, BB underscore basic. I'm going to call it basic.
That's actually my default name.
Basic?
Yeah, BB
Okay.
underscore basic.
Okay, BB basic. BB basic. Now I've put its parent to itself. It doesn't really matter. But self actor is the first thing that you're going to get in here. It's just default. You can reference your own AI. We're going to add in two very basic variables. The first one is going to be an object variable. We're going to call this one target actor.
So a very important note here, because people, yes, this thing, change the type of your actor key to something like an actor.
Actor.
Because the default value is object, and then
Object,
people try to use the target actor, like this kind of key, as a move destination. What?
What? Oh no, you don't. Okay, I see.
No.
All right. You don't want to.
Okay, I can shut up if you come on.
No, I was going to ask if you wanted to mess around with it. But
No,
all right,
I
all
don't.
right, all right. Never mind. But no, that is correct. That is very important. I'm not making fun of you. I was going to pass it over.
It's
'cause you're doing
just
a great
usually
job.
people. There's every
Yes.
month or every other month
Oh,
someone is
oh,
asking
no.
question on the Answer Hub.
It happens a
Why
lot.
why those keys are not showing up
So
as a movement destination, and that's because the base class is not set.
Yes. So object actually doesn't return what you need it to. So you need it to know that it's a subclass of that, which is actor. At the very base, actor. So actor is going to actually be the best one for our generic AI example anyway, because we're going to be passing this to anything. Like I'm going to make a box in the scene, and that thing can be usable, and therefore that is an actor. We can make a target. So anything in the world could be a targetable actor now. The next thing that we're going to need is a vector. I'm going to call it location. You can call it destination, what have you. And it's just a vector. There's nothing special to this. This one I'm going to be using for finding a random place to go to. If I don't have any targets, I should just find somewhere to be and sit myself there for a bit and go somewhere else and sit there for a bit. This is one of the most basic kinds of AI movement you can add is a wander. So we'll do that in just a second. First, we need a behavior tree to hold that logic in. So we go back up and right click and go to the artificial intelligence menu for a behavior tree. And I'm going to call this one BT underscore basic because I assume that one's cool. It's a good name.
Yeah, that's a good name.
That's a good name. All right. BT basic. Now BT basic by default is going to be assigned the Blackboard asset BB basic because it's the only thing that exists. There's no other default one, which is pretty useful here.
Yeah, you don't really. I mean, having a Blackboard is not necessary to use behavior trees, but there's a lot of convenience features in the behavior tree nodes and tasks and like all kind of nodes that use Blackboard. So there's no reason not to use it. I mean, you could, but amount of things you would be able to do would be seriously restricted.
Yeah. Now I have a question for you.
Yeah.
I have BB basic here,
Mm-hmm.
and I have it here,
Mm-hmm.
and these are all here.
Uh-huh.
But why aren't they here?
You haven't saved it.
I did. I just saved it.
Save, close it.
I'm gonna save it.
Hey,
Okay.
Close both.
Okay. There you go. I don't know. It just didn't like me for a second. Okay. So for what we're gonna do now, I'm gonna do I'm gonna drag off of this root. So root is where everything comes from, but you can't pull logic straight out of root. You need to find a way of deciding what you're going to be doing. So your decision making comes in the form of composites, selectors, sequences, and simple parallels. We're gonna start off with a sequence, but actually you're gonna want to start off with a selector normally. But the sequence is all that we need since we're going to just be doing a simple move to, or I guess it's just move to. Move
Yes.
to. And we'll move to, and here's the details over here. We move to Blackboard key, location, and then we're just going to do a simple wait for, I don't know, 3 seconds is probably fine. So we'll do a wait for 3 seconds. So we're going to move to whatever the vector is for location, and then we're going to wait there. And that's the entirety of this logic as it is right now. The sequence says, run things from left to right, and if they succeed, move to the next thing in the right. Otherwise, fail upwards.
And there's no upwards.
Yeah, there's no upwards here.
So it's not a good idea to have this kind of behavior tree.
This should never be your base behavior tree.
Yeah, because if something goes wrong, it will, the next tick, it will try again and again and again.
It'll just lock up. And actually, that's what's going to happen. You're going to see it's going to lock up once we actually complete this move to. Another thing that we're going to do is we're going to set the move to's acceptable radius to 50 instead of 5, because 5 is a very small radius of success, and you might not quite land in it. So in order to do anything with this information, we're going to need an AI controller to inject it into your actual AI thing. Whatever your AI is, I'm just going to call it thing. It doesn't have to be a person. It can be anything. So we're going to go right-click in
AI
this.
agent.
Agent, sure. Actor.
Like Agent Smith.
Sure. So that's a person. I mean, okay.
He's a program. He's a program.
Aren't we all, though?
But he. Like, I'm referring to him as a he, so
yeah, the program.
It's a person program.
So I've opened, I said right-click blueprint. We're making a new blueprint, and I didn't, notice I didn't use any of the defaults. I just did blueprint class. We're going down here into the search, AIController. There's Detour Crowd AIController also, but we don't need to worry about crowd detouring right now. We only have like a couple dudes in the scene. It's not necessary. And so I'm going to call this one, I guess, Con Basic. So AIController Basic. AIController Basic is going to hold our very simple information in it as far as just what the location, like for just display purposes, I'm going to inject what location is and just have him walk to it and wait there. And so you'll understand kind of the basis of what this means. So first thing, when we begin playing, we'll have control of some kind of a character in the world, but the character's not going to have a brain. So that's a problem. We need to give him a brain.
Okay, yes. Because there's a couple of ways of spawning AI. What you're setting up is going to be a pawn that you put on the map, right?
Mm-hmm.
And with this setup, there's no way to tell him in the properties like which behavior tree to use. But if you spawn AI dynamically,
yes.
Using spawn AI
AI from class.
Yeah, you can specify the behavior tree directly here in properties.
Yeah.
And you don't need a dedicated AI controller because you can have it use the default AI controller and just specify the behavior tree here, and it will just work. But the downside is you need to this works only for spawning AI dynamically.
Yes.
Which is, the higher level thing.
Yeah. So since we're not going to actually be spawning in our AI, I'm just going to inject the behavior directly into whatever we add the AI controller to. So basically, I've got this info here, and if I take our character in the world, and I'm going to move him over a little bit and back, and I'm going to hold Alt, and then drag him to make a duplicate. And then down here in the settings, I'm going to scroll all the way to the bottom, because that's where this stuff is. It's going to say actor, pawn, not actor, pawn, auto-possessed player, disabled, because the first guy, this guy over here, is going to be the one that has player and like input controls from the first player, which is me, and I'll control him. This one over here will have none, and since it doesn't get possessed by a player, it should get auto-possessed by an AI, and that AI is going to be AICon Basic. So that is now connected. Now that they're connected to each other, it knows that once it spawns in, to tell the thing it's connected to get the behavior tree of BT Basic. So now it'll run BT Basic when we load up the world. But it's not going to have a location pre-built, so it won't know where to go. So I'm going to fix that really quick. So I've made a new variable, and I'm going to call it location, just because keep it simple. We know exactly what we're messing with. Now
Can you run the behavior we have now and show the BT
show the
debuggers?
lockup. Yeah, I can show that.
So
okay.
that people see how broken BT
Like
looks
what we
like.
have right now is going to make him not move. And if I go into BT basic, you can see he's trying to move to location, but he has no location. It's invalid. So he just locks up on it and he can't do anything. And this is bad. Like this isn't going anywhere. It's very unhappy. And
you don't even see it on.
it's happening so fast you can't even see this constant up down failing. But if I hit pause up here, we can actually pause the game and then run back in the AI's thought process and say, oh no, look at it, it's just failing. That red line means failure. The white line means attempt. It attempted to and failed. So what we need to do is give it a location to go to. Now, I'm going to show you how to get locations in a bit, but first let's just show you how to direct inject a location for the sake of injecting a location. So I've made this new variable, I named it location, and I changed its variable type to name. A name is actually a really interesting way of doing this. So what we can do is we can take the name, and I can also say get controlled pawn. So the controlled pawn is my robot in the world, is what I guess I should think of him as. And he has a behavior tree attached to him, which has a blackboard. So I'm going to do get blackboard. Because what we need to do is take the blackboard, which is a struct of variables, and get that vector variable and set it. So let's set.
Is the blackboard on the pawn?
This is how it's always worked for me. I mean, you tell me. I mean,
it's usually in the controller, but it's possible.
I think that this might actually talk up to the controller.
We reroute the.
I think that might be what it is. So you might not even need that. But I've just always done it that way. I guess, yeah, you're probably right. It probably just reroutes up through the controller.
You should be able to just remove the get controlled pawn node.
Yeah, we'll just test it out. Yeah. We'll just test that and see how it works. But location is the name. And what I need to do is compile real fast. Okay, so location, you'll see I've set the name of the name variable to location, but the value is what's actually important.
Yes.
So we go into the default value and we change the value to match that and say location. So location is now the value, which gets really tricky when it's a name that has a...
That's why the variable shouldn't be named location, should be named location key name.
Location key name, you like that? Okay, let's call it that instead.
That would be clearer.
Location
because it's not location
key name.
You're not storing location in it.
You're right, it's the key name.
I know.
So the location key name is location. So we're transferring that info over here. So what this now says is run behavior tree, inject this brain into your guy, then reach into his brain and tell him, find whatever location is, whatever we've named location, and set it to be this vector value. Now, I did a little bit of messing around before, and I got some numbers to put in. So 180.
Or we can do it properly.
I'm just getting some numbers that I made up that are in the world. It's
but
a place
show
in
people how to do things properly so that they can,
Okay, sure. I'll show them how I did this. So
to make their life easier in the future.
I grabbed a block in the world, and then I looked at its location.
Okay.
And then I just typed in those numbers.
The best way would be put a node on the level.
Yeah.
Put a node actor on the level. So that's the way, we used to do things in Unreal 3.
Yes.
Go to the level, the viewport.
Okay.
Put a... Come on, don't do that.
I'm going...
Put a note.
Okay, a note?
Note.
An actual... wow, I haven't put a note in a level in a while. Okay, it's a note. Look, it's
put
a
it
note.
Anywhere you want this AI to go.
It's right there. It's a note.
Because you can then use it, to change the location, even in simulation mode.
Okay.
And then, you know how to proceed? No?
No, I mean, I can go in here and I can get it from... I can, do get all actors of class, or I can just get the...
You're right. That wouldn't work.
What?
Because it's not a
We're not a level blueprint. Yeah. No.
Okay, you're right.
This isn't a reference in...
Go. You're right.
Okay, can I do it my way now?
Yes, you can. Yes, you can.
Thank you. Thank you.
Because usually you prototype stuff in the level blueprint where you can reference things that are on the level, and then you could just use it, plug it, put it here, use the get actor location, and plug it into the vector value.
Well, yeah, I mean, that's true. We just do get actor location of something.
But you're right. This is a controller which is level agnostic.
Yes.
And you cannot put level-specific references here.
Yep.
Yeah. Go
Okay,
ahead.
cool.
Yeah, I was wrong.
All right, no, I just
I
letting you explain.
admit I was wrong.
I was just letting you explain that. So
Sure.
okay, so
Go on.
so what we're doing here when we're just direct injecting some numbers is I've figured out that there's like a vector out here by I clicked on one of these, just grabbed the numbers out of the location, and then I sort of messed them around a little bit. And what I came up with was like 180, -670, and 150. And this will put you somewhere in the middle of that block over there. But the point is, it has a value now. So when we start up again, he should have some numbers. So he tries to run to that block because it's somewhere within that block he's trying to get to. And that's it. So we set that number, and now you know whenever you need to set that, that's just one way you can do it. You can hard set any number inside of his brain by just saying get the Blackboard and set value as vector. I didn't need that controller at all, though. You were totally right about that. So yeah, it's really good. But that's just an example. You don't need to necessarily create a complex system to get your AI to go point A to point B. Just inject a number, make him go there. So we're going to get rid of that because it's not what we're going to be messing with in the future. I just wanted to show you. So that's about that for in here. We're going to jump back out of the AI controller. Now that it injects the brain, that's all that we really need it to do. And what we want to go to next is making the Blackboard here find a... Oh, am I still simulating? No? Ah, there.
That's interesting. Close it, open it again.
I don't know what...
that's a...
Why are you making weird stuff happen? Because
that's BT debugger.
Oh, yeah.
Nah! Don't delete
deal
stuff.
with it. So I'm just going to remake that real fast since it decided to trip out on me.
So a quick comment, the root node you start the BT with, you as a user, it's not an actual root of the behavior tree, it's a node that we have only for the editor so that you can specify BT's properties. The only property we have currently is the Blackboard asset, but if in future we wanted to introduce further properties, those would be there as well. So you can, as you can see, you can only have one child of this root actor, while if you place an actual selector or sequence node, which is a composite node, you can have like any number of children.
So this is important because what I've done here is I've now added a selector, which is going to say that the first thing here, which is going to be another sequence, I'm just going to draw it in here, sequence. If this fails, do this. But if this succeeds, then forget about anything below it, which is the opposite of a sequence, which says if this succeeds, then move on to the next thing. But if it fails, just fail up and don't do the next.
And that's why a good idea is to always have a fallback behavior that can never fail. Usually, for me, it's just a wait node, so that I can identify that the behavior ended up in a node that I wasn't expecting. So you can easily find it in the logs or in the while looking at the behavior tree in the debugger. And it's like a wait a second and then retry. And it also saves you from the behavior tree looping constantly. That's why you could add a task like that.
Yeah. I'm gonna just
sure.
I'm just gonna make that one though, and then
I didn't mean to go off script.
No, you're fine. You're okay. That was good info. It's fine. Sorry, I don't want to make you paranoid about talking about things.
Yeah, I've noticed you do want to make me paranoid.
Wow. So
even more than I am, because I am paranoid.
Oh jeez.
I'm kidding.
I bring you on streams.
That will teach you.
I have learned such a lesson. So what I'm going to do here is, sorry, I started pressing buttons. I made this sequence here, but it has nothing under it. Well, we're going to start putting info into it. So I went up top here and I hit new task, and that spawned in a new blueprint task. It's a behavior tree task, I should say. A BT task is something that you can run as an execution, like one of these. There's also decorators and services. A decorator works sort of like a gate or a checker. It makes sure that certain values and settings are a certain way before letting you activate or deactivate certain things. A service runs a constant tick of some sort of information while passing through. So it attaches itself to one of these composite nodes or to a task itself. Yeah,
Sure.
So to a task, same thing with the decorators. And what we'll do here is we'll go on ahead and make this base task. This task that we're making, which shows up immediately next to your behavior tree in the content browser, will be called find random location. So that will be exactly what it does. We're just going to go in here. We're going to go under the functions, and we're going to add in a receive execute AI. So when the task rolls over and hits this, it hits the execute node for receive execute, which then in turn triggers all the things. So what we need this to do is take the controlled pawn and get the location of your controlled pawn. So wherever our robot is, we need to know that so that we can find a random place within a certain reasonable area of him. And then from this, we'll want to do get random point. So there's two: get random point in navigable radius and get random reachable point in radius. So navigable means what it sounds like, anywhere within navigation, and then reachable is something not only in navigation, but we can also actually get to it. It's not like off on a platform somewhere with no connections. It's a very, very important distinction when you're designing your levels. I'm going to set the radius to 3,000. That's just a number. What?
How about making radius a task parameter? So that people know you can do that.
Okay, yeah. No, that's a great point. That's a great point. I'm
gonna
make a new.
script,
I'm gonna make a. I'm gonna make a new one. No, this is a good one. I think this is very valuable. I'm gonna make a new float, and I'm gonna hit the I button right here. So the eyeball opens, and that means it's exposed. Which actually reminds me, in turn, I need to double check something. Yeah, is usable. I did expose that. Never mind. So it's exposed, which means that the task, like if I select this task here, you can see it's like task ignores restart self. It's got a couple things in here. Well, now this should appear as a parameter of it. And
like
we will plug that right into there. Radius. It's exposed. We can change the radius. We don't need to worry about nav data or filter class. And then what we'll now do is we'll build a location key. So this, let's change this into a Blackboard, and I'm going to explain this kind of variable type here, a Blackboard key selector. Now, you actually know the background like of all the code behind this, so you might be better explaining it, but I'll just give like a rough overlay here. Basically, the key, which I need to expose, also will create one of these small, this right here, like little drop-down menus. You can actually see this one says Blackboard key. And out of that, it will let you pick from the Blackboard whatever variable to inject information into, so, or take out of. So in this case, we're going to do set, and then we have Blackboard, blah, blah, blah. Set Blackboard value as vector. The vector value will be the random number. And we're going to, I saw that. And so what we're going to do is take that and inject it here. So the location key, we can now set to whatever, and it's going to plug in that vector value. And then, very simply, we're going to finish. Whoops. Helps if I spell that right. Finish, execute. And we're going to say success, because succeeding or failing matters in our behavior tree, which is why they have a Boolean value here. Yeah. You might actually force a failure, even though it went the way you wanted, just because it's helpful to fail instead of succeed in that instance.
So one of the common mistakes is not calling the finish execute.
Yeah, very common.
Which results in a task just hanging.
Yeah, just hangs out.
Yeah.
So this is really important to remember. Always go in and make sure task finishes at some point. Otherwise, it will just hang out in there because it needs, like, the service, for instance, is going to think, well, clearly you're still going, so I need to keep going, and things like that. So
yeah, AI will just stuck.
Yeah.
Which looks broken and is probably something you don't want to have to happen.
Yeah. So we don't have to do anything special now that we made that task. It'll just appear in the list of tasks.
Should. Disclaimer.
Does. Here it is. Find random location. And then we're actually going to, I can just copy this over, move to location, Control-C, Control-V. And then, why not wait? Pow.
So why do we have the second sequence?
You know what? We don't need it. You're right.
Okay. That's perfect.
There we go. So now we've just replaced that sequence with our random one. Now let's actually put some parameters in here.
Yay.
Since this didn't have anything, let's put in 3000. This can be any number now because, like you said, we've parameterized it. So it's just up here under radius. Location key is going to be location. So once we get that random thing, we're going to feed it off there. And that's about it. So now we should see him just picking out a series of random locations, stopping for a second, and then moving to another random location. Where'd he go? There he is. Yeah, so now he's just picking random spots and moving to them. And this is actually probably really good for just about anything that's not smart AI.
You can show people a glimpse of AI debugging tools. You can.
Yeah. So here's him making his decisions.
I didn't even mean that. But yes, that's cool. That's cool. That's cool.
Here we go. So let me just back it up a few times. We can watch the thought process. So this was him after going through stuff and waiting. So he waited somewhere. Next, he found a random location, and we can see the location over here. We'll update. See that? It's different. Now we have a new location, which he's moving to off of that location parameter. And once he reached it, he waited. And you're just going to see it keep cycling through. Find location, move to location, wait. Find location, move to location, wait. And that's exactly what we programmed him to do.
Yes.
And it's really great for if you have a forest full of little wild critters, and the wild critters don't need to think. They just need to find somewhere to be and put themselves there. And this might even be overkill for that.
Yes,
but,
might be.
Might be.
But our behavior tree implementation is really efficient. So don't worry about running hundreds of behavior trees. We actually do run hundreds in Paragon, for example.
I mean, look at Fortnite. It's just tons.
No, there's more in Paragon because every minion has a behavior tree as well.
Oh, that's because the Fortnite ones kind of like share like logic and do like a bunch of weird crap and all that. But the minions in Paragon all have individual thought processes, which is that's kind of bleak now that I'm thinking about. We're like killing them, but they think. Wow. Yeah.
All those.
Oh, the poor little
thoughts. Can you run it again and show the gameplay debugger?
Oh yeah. So actually, I was going to do that after adding perception in, so you can see the perception too. But here I can
that's fine.
Okay, but here.
Now we gotta find the guy.
Well, he ran off. So there you go. Get back here. So if I hit the apostrophe key, we'll enter into debug mode where we can actually see him choosing his pathing as he goes about. And there's a ton of info here. And off the numpad, I can hit different things to turn on and off different bits of info that I need and don't need. I'm not using EQS right now, so I don't need it. The behavior tree, it'll tell me what he's doing, but I don't need that. And if he had perception, which he'll have in a bit, we could see that too. I'm going to just leave this one on for right now. You can see when he chooses, that's the nav mesh chunking that he's using to figure out where he's going. And so he only has to process that much of the nav mesh to figure out where he's going.
What? That's his navigation corridor. So
corridor.
That's the nav mesh polygons that build the final path.
Sorry, I thought that's what it sounded like I was saying. But yes, that's what I meant was
that's cool.
It chooses the nav mesh chunks. If we're not calling them chunks, are we calling it a corridor? I didn't know it was that. I mean, that line it draws is the corridor, right?
No, this whole thing is a corridor.
Oh, okay.
Those are nav mesh polys that build the path.
That's interesting. I always thought of them as chunks. I didn't think that was called a corridor. I learned something new. That's all.
It's a corridor.
No, it makes sense. It makes perfect sense to call it like a corridor or hallway or something. Cool.
Anyway, yes.
Yeah. So that's how they kind of just use certain things in order to use instead of using the entire nav mesh at once. They just light up certain sections and calculate that. Next. So we've added in. Whoa, what's this? We've added in the find random location stuff. We've opened it up and shown you that new task. Now what we need to do is start thinking about how do we find something that's usable and then go to it and then use it. So that's the main core of this. So when we actually get through and build all these things out, we can then move on to taking, where did it go? Under AI, we can take the controller and we can add perception into it. And the way that we can do this is very simply, we add a component and we go AI, and then we have an AIPerception component. It's all good?
Yeah.
Cool.
Yeah, and remember to add the AIPerception component to the controller. It
Yes.
should work on a pawn, but it's designed to be used on controllers.
And this is important because if it's on the controller, any pawn that we inject into this controller, I guess, it instantly gets its own thought process and pre-built senses and all that. So we don't have to make a separate one for each individual guy out there. They can all just run off of this one, and it instantiates onto each of them.
Yes.
So through this, we'll go over, and we're just going to set up. We're going to set up the AIPerception from start to finish, very basically with just sight. He doesn't need to worry about the other senses quite yet, and they all work relatively similarly. So dominant sense is going to be sight, which we're going to click here.
If you have just one sense, it doesn't really matter which one you set to. Well, you don't have to set the dominant sense, because the dominant sense variable value is used to determine whatever the perception process thinks is the actual location of an actor if you have conflicting information from different senses. Excuse me.
Okay. I mean, yeah, it's important.
That's fine.
It's important to know.
That's fine.
No, but if you're going to have multiple senses, then just make sure to set up a dominant. But if it's just the one, then yeah, he's right. There's no reason. I'm just doing a couple of things for safety's sake because I assume you're going to want to expand off of this. Let's see here. Next up in this, we're going to add in just the configuration. So under the senses config, hit the plus button, and then a little new drop down will appear. From that, we're going to set up your site configuration. Drop down this other sense information. There's two little arrows. And we just need to do detection by affiliation. Since we're not working with teams or anything like that, let's just detect everybody using this. So detect, check all the checkboxes, enemies, neutrals, friendlies. Anything else you'd want to have me turn on here? Because that
should work.
That should work, because that's all I'm going to do, unless there's other things you'd suggest. And that will give us the ability to look around. And now if I hit play and I hit that debugger again, when he runs around and I hit 4, the number 4 will allow me to see his perception setup, which is a faint green line. I don't know if it's going to show up very well, but you can see that faint green line there. That's actually his debugger, and as I enter it, you can see I get a green ball, and that's him seeing me, because he can see me.
Yeah, and when you're behind him, he cannot, because you set his peripheral vision to 90.
Yeah, he has peripheral vision to a certain degree, and then I can get out of his vision. But this is important because now he knows, like, basically that I exist, and he can see me.
He can know.
Yeah, he can know me, and he can then transfer that information. So let's go back to the AIPerception here. And then on perception updated, that was that little ball showing up was the update happening. We're going to make this event called on perception updated for the AIPerception. And then off of the updated actors, I'm going to do a for each loop. Oops, actually I'm going to do this with a break. So loop, for each loop with break. So when we run over actors in the world, we're going to just scrub through them real fast and see who they are and judge them according to various values we've set up. Now, if you'll remember, we put in that interface, but it says implement interface, not add. So let's look up to see if something does implement the interface. So the isUsable interface is what we're going to check against for a lot of our logic. Use. So, whoa. Oh, what did you make me call it?
Usable.
Usable. Yeah, usable thing interface. There we go. So we've added in this node, which is a check, to see if the target, which is everything that's entered into his line of sight, if any of those targets do in fact implement the interface, usable thing interface. And you smacking the cat?
Yeah.
Okay, great. So we can then branch from there. A branch is essentially an if statement. If you're not familiar, you can actually type in if, and they will show up. See, if makes a branch. Look at that, super cool.
Yeah.
Or we can press B and click in the world anywhere.
Ooh.
Lots of different ways to make a branch. It's very common.
It's confusing.
No, it's not. It's helpful and convenient. And then from that, we now can, this is like working as an is valid check. We're knowing, we now know whether or not this thing coming through is in fact a usable thing. From there, we can say, hey, usable thing, can we use you? So we're going to message out to that thing, and we're going to activate can use. There you go. There's that little thing we made earlier, and I'm going to make some reroute nodes so it's a little cleaner and you can see what we're doing. So the you're having so much fun.
Oh yeah.
So can use was the value that we've created here in the top-down guy. Like I said before, all it's doing is passing in the isUsable variable straight out here, and so we can just make another branch from this. Ta-da! That's all that we need to do our check. So our check says, does it have the interface, and is it something we can still use, even though it has that interface? We're not sure if it has been used before and cannot be reused. From that, if that is all true, all of that is true, then we're going to want to set some stuff. So let's get Blackboard again. So we're going to want to set the Blackboard's target actor, because now we know this is the thing we want to target. It entered our site so we can see it. It's a thing that can be used, and it's not checked off as being unusable. So is usable? If so, set value. Let's do set value as object. Now we're going to need to make a new key name, so we're just going to change the location key because we don't need the location key anymore. We're just going to change this to actor key name, compile, and then we're going to change the the actor key name variable default value into target actor, which is what we called the Blackboard variable. So we want to change that variable inside of the
Blackboard key.
Sorry, key. It's a I mean, is that really I guess that is a big difference.
Well, you have key selectors for Blackboard, so
yeah,
they select values by keys.
Okay.
It's a kind of a map.
That makes a lot of sense. It does. So now we've told it this is the key to look for by name, and the Blackboard that we're going to be using, or we're trying to get to. Okay.
The cat.
Yeah, no, I gotcha. No, I saw it.
How about...
It's my cat.
Not anymore.
Oh. So finally, we want to set that value to be whatever this approved usable thing is. And if we do approve that usable thing, then, whoa, break. Cool.
Yeah.
And I'm actually going to add a reroute node so this is cleaner. So otherwise it'll just complete out and nothing will happen. And we won't get any updates, and that just happens sometimes. So he's just not going to see something usable all the time. So that's what perception is. The perception just creates the overlap event. The overlap event then drags all that information through here. We parse it out and validate that it is, in fact, what we want. And then we reach up and we tell our Blackboard, hey, find the target actor and set it to this. Cool. So that's how you pass that information out to your Blackboard to get a target actor.
For example, yes.
For example, yes. So cool. Now we have that info, and what we're going to do with it is we're going to immediately put it to use so you can see it in action, and then I'm going to move on to the actual usability. So now we've got the ability to find a usable thing. I'm going to add in a sequence into our Blackboard, and we're going to say in here, add a decorator. The decorator, like I said, is a gate. We're going to do a let's see here, Blackboard decorator. And what the Blackboard base condition decorator does is it lets us say notify observer. So this is our observer. So notify us on value change And the observer will abort lower priority. So this stuff's lower in the chain, starts to the left and moves its way down. So if we are to set our target actor to something, we should stop wandering randomly, because that means we saw something we want, and we should move to it, right? So we'll do move to, and we'll change it from self actor to target actor. All good? Cool. So he immediately walks right past me and ignores me. So I need to figure out what I did, where he didn't get a target actor. Okay, so I open this back up.
Yeah, the target actor was not set.
Is set.
It's not being set.
It's not being set. Oh, did I miss the target actor set value?
You can put breakpoints here and then
Yeah.
see.
So let's just put a breakpoint in here and make sure that he's actually seeing stuff. So I'm going to put a breakpoint with F9, and we're going to see if we're actually getting to the point where he's seeing something with an interface. Hit play. He ran away this time, so now I got to catch up with him. Get over here. Yep. There we go. Yep. And you know what it is we hit can use, but by default, can use is deactivated.
Aha!
So
see,
what we need to
debugging
do,
for the win.
So, well, this was great. I got to actually show you why you want to debug these. So, since we exposed is usable earlier, I can just go into the defaults of our guy and check on is usable.
Aha!
There, now he'll pass that check.
Perfect.
And now when this guy sees me, he will
Peekaboo.
pow. Well, he hits this branch. Should deactivate that. And then I can't resume. I have to escape, of course.
There was a button.
There was a button. But now he's going to chase me.
No.
And he's just going to chase me forever. And so now we have a basic chase. He doesn't have any other logic. He doesn't know when to stop chasing me. And once he catches me, he just starts losing it. Look at this. He's just like, I don't know what to do. I got you. I got you. And I don't have any instructions past that. So he moves to the target actor. And then we need him to do something. So the thing we want him to do is use, right? So let's make a new use. So let's make, let me scroll down a little bit here. The last thing in this tutorial will be the most ultimate of them, the thing that actually does stuff. So we're going to make a new task by clicking on here, just like we did for the find random location. And we're going to do this not based off find random location, but the BT task blueprint. It opens up a new one, but we're going to rename it in here. It shows up again next to this. Getting a little over time. I'm sorry, guys. And then in here...
Well, not yet, right? Do we have a time limit, actually?
No. I just try to keep these things like in an hour, but we're at 1:15. So here at our task, this is going to be use object, I guess is what I'm going to call it. Use object. That's objects. I did that funky. There we go. Use object. Use object now is here, and it also will just immediately appear in here. Use object. Ta-da.
Like magic.
But we don't need to just inject it quite yet, because we need to put in some variables first. First, we're going to need some keys. Target actor key will be our first key. And then, let's see here. We're going to need, sorry, checking my notes really fast. We're going to need to make this into the actual key type. Key, Blackboard key selector. There. Cool. And now we're going to make a new event. This will be event receive AI execute. Execute AI, I should say, sorry. Now you'll notice that there's two different kinds of executions, execute and execute AI, but there's this for all of them. And basically one of them will return the controller only, and the other one gives you the controller and the controlled pawn, which is important. We need the controlled pawn, so we just might as well skip. Normally you just do this and it's like get controlled pawn, blah, blah, blah.
So the non-AI version is there because you can use behavior trees not only with AI. You can use behavior trees. I know there are people that are using behavior trees for a UI flow, for example, and you can embed this logic in other places. When you have both implemented, and you don't have an AI controller, the other will be called. But if you use the same behavior tree with an AI controller, the version, the execute AI version will be called.
Yep.
It's just flexible this way.
Great. All right, so I'm going to take that target key, and we're going to do get Blackboard value as object. All right, so now we have the actor in question, and we can actually tell it. We can actually do does implement interface. Ta-da! So we can actually double check this too. As well in here, we could do this in the logic of the use function or in the logic of wherever, as long as we get that logic in there somewhere. I just wanted to call it after we've discovered things, and we were not going to get much further without discovering things. So actually, this is just going to be an is valid check, basically, that I don't need. Usable thing interface. So, but it's just going to be helpful for doing valid check branch. Cool. So now we know that it does in fact implement that again. Use target used. So from that actor, we know it does have usable functionality. So we're going to try to call used on it. And the using actor, which I think I said usering actor, actually.
That's fine.
Okay, well that's just great.
That's English.
Yeah, and is going to be our controlled pawn. So now when we get used, we pass in that AI that's using it. And I'm just going to set this this value like you did before. We said let's parameterize it. Sure, why not? I'll promote this to a variable and call this value. And then I'll expose it. I got to expose both of these actually. So that's the gist of that. But what we also want to do is call use object on the controlled pawn. So the robot that is doing the using should be told, you're using something, perform your use animation. And then the thing being used is being told, hey, you're being used, prepare to receive values. And then after that, we'll do a finish, of course.
It should actually be, you should be calling function only on the thing you're controlling. And if it has any effects in the world, like a thing being used or like opening chests, this shouldn't come from AI logic. This should come from like the action the agent is performing. So we should be, this is fine for prototyping. The actual sets should be, setup should be, we're calling a function on us, use this object, and then inside the function of using this object, we would call use object on the object inside the function.
Okay, that's interesting. So the way that you would set it up is instead this would say use object. Within the functionality of use object, it would then reach out and touch the thing we're using.
And call a function on it.
And call a function on that. So that's a good way to do it.
That would be the clearer way of doing things, because you can have some logic in your use object or function that forbids you from actually using it. And your brain might still want to use it, but the mechanics of the world don't allow it. So the AI logic should be just requesting actions, not making them happen in the world.
Okay, all right. That's my bad, I guess.
No, that's just a good rule of thumb while working on AI.
Okay. The last thing I'm going to pass in here in my little logic thing is I'm just going to pass this because we did the used object should be. I must not have set this to a proper, because this is an object and it wants an actor. But we could pass in whatever other logic we want to the used object. And actually, if we open up this, we'll see the functionality in the interface. So cool. Now we have use object, and I'm going to have to exit out of here and reopen it to get the new functionality. I might even have to like save and reload. So yeah, let me compile.
Yeah, you have to compile
save.
it.
Compiling it makes perfect sense. Yeah. Okay, now we can see there's all my parameters I've added. The target is now target actor for the target actor key, and I'm gonna make value of 1. So we're just gonna add 1. All right, and then that's about it, but I'm gonna put in a small wait, so when he actually comes up and pokes you, he'll stop for a second so we can see that he's doing something. I put it for 3 seconds. And so now let's kick off when we have a target actor, move to the target actor, use the target actor, and then wait for a second. And then part of that use is actually going to make me unusable because it turns off the use as we said it before in the functionality. So he's only going to try to use me once, and then he'll move on to doing something else. He's going to come up, he's going to poke me, and then he's going to keep coming for me. Oh, you know why? And actually it's written down here in my notes, and I totally skipped this one note. He's going to keep coming for me because I'm still set as target actor. In the use object, we actually need to take the key actor here
And clear it.
and clear it. Yeah.
Ah,
Ha 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 ha. Sorry.
perfect.
It's like it's right there in my notes.
good.
A clear Blackboard value, and I went
good.
right past it.
That's good.
Okay, so this is an important note. You need to make sure that once you've used something to clear it, or else it will stay in their memory forever and ever and ever. So now he knows once I've interacted with you, I'm done thinking about you. We're over. Goodbye. And now he doesn't care about me anymore. And now he's gonna have a really hard time caring about me. Like I enter here, he doesn't care. He does not care. So what is it? I think it's okay. So I am going to eject out of him, select him here, and if you see my is usable got turned off. But if I turn it back on, I am now usable and I'm interesting again to him. Now he has interest in me, and I can put myself in the world, and hopefully he'll catch on to my presence. Oh wow, he unchecked it again.
Because he had
already
used you.
see, there he goes. He did it again. He just used me again. But if I possess again, whoops, ha ha ha. I possessed him, but he didn't have his camera set up. But see, I've got that 1 now, which is great. So that's awesome. Now he can transfer that 1 to me. I went at 0 and I'm now at 1. Yay!
Yay!
So that's it.
Stuff works.
Yes, so that's just how you can easily set up a series of thought processes for run around, find something, transfer information, and all that. And don't forget to duplicate, I guess, your idle animation, or at least reset it, because otherwise you'll end up with what I've done here, where I've set myself up with an idle. But he used me. I've got a 1. Dang.
I feel so used.
Yeah, but that's it. That's using to its T. Now, to expand off of that, I could apply that is usable functionality to a block in here, like turn this into a blueprint, apply the is usable interface, because that's what it's looking for, is an actor with that interface. And then I could just give it that variable value and then feed it into the function for can use, and then it'd be done. It's anything in the world now is a usable object that he can see and attempt to interact with and transfer data between him and that object. And as Mieszko said, you might want to actually take out the using stuff and put it into the logic of the actual AI
User.
Yeah, the actual user of stuff. But overall, that's the general functionality of it. We have quite a few questions coming in, so I'm going to answer these for we're going to answer them together, the
Sure.
Q&A section. And wow, thank you all, Adam and Samantha, for getting these questions. So we have a few from the forums first. The first question is, what would it take to get nav meshes on moving platforms?
A lot of coding.
Coding.
Nav mesh on moving platforms has been actually sitting on our to-do list for a long time now. And it would recast out of the box doesn't support like moving nav mesh elements. You can there's a couple of ways you can try and set it up now. You can have a moving platform within a world with a constantly rebuilding nav mesh, and it would work in a sense. You would enter a platform, the platform would move and stop somewhere, and then you can get off the platform. But as long as the platform is moving, it will be constantly rebuilding nav mesh, so any path generated on it will get instantly invalidated and could be rebuilt, or would be rebuilt all the time. You can use non-nav mesh pathfinding, like straight move paths, while on the platform, and then you can, when it stops, get off and use the regular navigation.
That's what I was going to suggest. It's just like a bunch of force movements.
That's the simplest fakey way. The proper way would be have when you enter a moving platform, you create a separate recast nav mesh that's local to it, and that doesn't care about the object moving through space, and you could navigate on it. And then when it stops and you want to get off the platform, have another nav mesh that takes over. But that's we don't have a support for it currently yet.
It would be something that needs to be added in, yeah.
Yeah.
Okay. I am trying to make these more legible so we can see them. Okay, there we go. I'm going to knock that one out. So yeah, the platforms are answered. What are the plans for AI and UE4 going forward? You're back in action making some stuff, right? Like, what are you up to these days?
Well, currently I'm still on Paragon,
Mm-hmm.
and Łukasz is on Fortnite. So is John. So all of our 3 AI programmers are busy with gameplay, like specific game projects.
Mm-hmm.
But we are still doing things. It's just a bit slower, and whatever we do for both those games, and there are other games that are utilizing this stuff as well in like in-house games. We tend to do things in a generic way so that you still get those features. I'm not going to tell you what it is, but I'm currently working on something for Paragon, which is going to be amazing. But well, it will make it to the engine in like 2 versions.
Okay.
But it's something worth waiting for.
So be looking out for like 4.16, 4.17, and
Yeah,
you might have
more
something.
like 17.
17, okay. Give yourself a little more time to work on it. Gotcha,
Yeah.
Gotcha. But,
But
so keep
yeah,
your eyes
and
open
in
on
general, the plan is to make it even more awesome. We could use some AI programmers, so if any AI programmer wants to.
That's actually AirTech just asked, need more? Question mark.
More AI programmers.
More AI
that's
programmers.
for sure.
Actually, this is probably a good time to plug. If you go to epicgames.com/careers,
We
you
actually
can-
have opened the AI programmer roles for Paragon and Fortnite maybe as well. Not sure about that, but I know we have one for Paragon for sure.
We have
100%.
a lot of new openings that I've noticed showing up on the career site.
We could really use some human power, human
Just
resources.
saying,
Yeah.
you know, a lot of people that I know out there, I've actually seen some amazing programmers say that they weren't good enough to like work here, and I'm going to throw this out here. Just throw yourself out there.
Give it a try. There's
just give it
no
a try.
harm in trying.
No harm in trying. Like the worst you can do is learn something like about how to program better, etc.
Yeah.
So
and get flown over to HQ.
yeah,
right?
maybe you get to
Meet-
come over
meet
and go down the
awesome
slide.
people.
Yeah, it'll be great. Go down the slide and not break your ankle and stuff, and it'll be super fun.
This slide is not.
The slide
It's
is not
fun.
safe.
No, it's
Yeah, but
yeah,
sorry, getting
it's not
back
fast
to
enough if you ask
they don't
me,
want to
but-
hear about all that. But yes, check out
Yes.
career site to answer the question from chat. Or do we have openings for jobs? Yes.
Yes, a lot.
What is the best way to make a large crowd? I mean, that was kind of like the detour crowd stuff too.
So the best way to have a large crowd is use as little animation as possible. It's not the crowd simulation
Yeah.
or AI logic in crowds the biggest problem. The animation is the biggest cost
Yep.
you pay. So if you can have 10 actors that are animating like in sync, I'm pretty sure you can do it, so that you don't pay animation evaluation cost every frame like for every one of them separately. If you can batch it up and have them reuse that stuff,
Sort of
it will be-
instantiate the base.
it will be a lot
animations and stuff.
faster. Animation is the biggest cost.
Yeah, and this is really important with noting things like sure, navigation may eventually cost you if you have several hundred things going on,
Yeah,
but even
yeah,
in
of
a
course.
large crowd, look at GTA 5, look at any game with like huge crowds in them that you're used to seeing, Watch Dogs, etc. And the crowds aren't actually particularly sizable. Start counting people and see how many is there, and you'll see
There's-
that they're all working off the same base idle animations, the same
There's
base
so many
walk
levels
animations.
of LOD in those solutions.
Yeah.
You just cannot do it.
Yep. Check out Assassin's Creed as another
I
good,
don't-
just lots of good crowd and AI and how it works. Good examples there.
2 years ago, not last year, but previous year, there was, I'm pretty sure that was that year, there was a talk in Nuclei conference in Vienna by the guys from the Assassin's Creed, and they described how they did that, what kind of budgets they had, and it's like very, very restrictive. If you want to have big crowds, there's a lot of things, a lot of corners you gotta cut. How about using boxes or like cylinders instead of animated meshes?
I mean, you could cylinder it up, just a ton of
Yeah,
them.
but that, if you stylize your game around it, why not? You can
Sure.
have hundreds then.
I mean, yeah, why not? It's gonna look a little funky, but sure, why not?
Sure.
Yeah. Let's see here. In the HMD template, the AI move to function makes the AI move to the VR origin. How can we make the AI move to the player's current position in the play space instead of the VR origin? Right. So in that case, you actually want to go off of the HMD location because that's kind of where they actually are. So like I know what you're talking about, where you teleport into an area and you have like that box of your room scale area to it, like in the VR template. And it's going to keep trying to get to the core of that origin, and as a player you can move around it and you're still within it, but the origin stays here. Instead, yeah, you're going to have to reach into the HMD component location itself and get that, because that's actually where their head is. And that'll mess with them too. Like if you've played Resident Evil 7 like I have, there's actually a few things that track your very, very particularly track your head and not like the overall position of you, and then they lock onto your face, and the bugs are really too much.
You played Resident Evil 7 in VR?
Yeah, it was great. It was
I've seen it on 2D screen, and it was already like.
It's intense. You know what? Aiming is easier though, because when you're freaking out, it's hard to get like the aim right. But when you're freaking out and you're seeing the monster and you're staring at it, it's like, no, die. So, yeah, I know it is pretty terrifying, Clint. But I wouldn't have it any other way. It sold me on PSVR, honestly. So next up. I'm going to mark this one off. Next up, behavior trees or controller, what do you recommend?
The question is misguided.
Yeah,
you need a controller to use
You need a controller to run the behavior tree, and that's how that works.
Well, actually, you need a brain component, but like in general, in the regular setup, you need an AI controller to use behavior trees. It depends which one to use. If use only scripted logic in your AI controller or use behavior trees, depends on the complexity of your AI. For anything more complex than a bug that just walks to a random location, I would use behavior trees.
Mm-hmm. Yeah.
It's just easier to maintain.
Exactly. Like I was saying, like that wandering thing that I made alone would have been overkill, but throwing in like one or two more chunks of logic, and you're going to need a behavior tree to manage it, or else you're going to be working off of a lot of sequences and like just coming up with your own behavior tree solution, basically. So just might as well use BTs.
Yeah.
What happens with an AI in streamed levels? How do I ensure that the AI has connected nav meshes?
Well, what do you mean connected nav meshes?
Oh, like if you have a streamed level and it streams in another chunk of another level, like the nav mesh, like it's going to have a built nav mesh on that.
For static nav meshes, this should work, because we do
like
have some nav mesh streaming. If you have dynamic nav meshes, it will just rebuild and work.
Yeah.
If you have any specific issues with this, just ask a question on Answer Hub, and we'll look at it. And if you found the bug, we'll investigate it.
Yeah. Is it safe to call variables like is usable, the Boolean I made, with spaces and special characters?
In blueprints, yes.
Yeah, in blueprints, yeah, that's totally fine. They have, I think, what is it called, like smart naming or safe naming or something. Like there's a special convention, there's a special function that we've got built in, which will, if you do camel casing where you like make an uppercase, it'll actually make a little fake space in between them. So it kind of likes that, I guess. But go figure. But that's blueprints for you. It's great. It works. It's really easy. Blackboard and behavior trees can be made in C++? Question mark.
Yes. And
but eventually you will have to get back into the editor and
not really. I mean, you can the Blackboards for sure.
Mm-hmm.
Well, actually, we do both in our unit testing. If you get sources from the GitHub and find the AI test suite project, you can find like how we procedurally create behavior trees and blackboards. You could just take this code from there.
Okay. So there's some examples out there, I guess. The Blackboard nodes in AIController and services are different when you want to access values. Why? The Blackboard nodes in AIController and services are different.
Maybe the Blackboard, the functions querying Blackboard. They are different. This is a different function set, and that's due to some blueprint editor restrictions.
Mm-hmm.
It's something that's on our list to address. It's technically difficult. It's not something that we made a decision consciously on, and we did that on purpose to annoy people.
Yeah, no, it's just limitations cause you to have
Yeah,
to
it's on our
kind of work around it a
on
bit.
our radar.
But all right, this next question: can we get a rework of the types? This is, I guess, this is a reference to Blackboard variable types because it says object is too generic. We need subtypes. So yeah, object is. You can do subtypes. That is available. You just have to hit the little drop down.
And it has been like that ever
next to it.
forever.
There you go.
Forever and ever.
Let's see here. Oh, this is probably like a high-level thought question for you. Do you think that deep networks in games will ever be a thing instead of behavior trees? My answer is going to be probably not so much, but
not instead.
Nah, yeah, no, it would be
not instead.
That is your core mechanic.
Because for some for cases like this, first of all, for a lot of for all the cases so far in games, you want a reliable AI that always behaves the same way in the same circumstances, or if you want some slight randomness, you introduce that randomness in the nodes or like places you want, or so that you can debug it and stuff like that.
Yeah, through some parameters that you can have like on dynamically just randomized.
The problem with deep networks is they gotta learn, or you gotta teach them. It's a nice buzzword, but
there was actually one that was made in UE4 that was kind of interesting. I'm trying to remember it was Kashar or someone, but
it was not deep.
There was a
like single.
There was there was a sort of like network, like a thought network kind of system. But what he had to do is he had to run several simulations just to get them a base level of understanding too. Because like you said,
they have to millions to have like really.
You have to have something to work off of and learn from, and therefore it has to be like in the wild for a while, learning stuff, and then come back with a base amount of AI, and then so basically I wouldn't suggest it for a game unless the game was built around that AI in a very, very, very specific way.
Yeah.
Because
I can
otherwise,
imagine a game that could use that, but
yeah, I mean, like otherwise you're going to end
worth
up
it for
with very strange scenarios where you're playing like a Call of Duty and the AI guy is like walking through a wall because he just decided to turn off like.
No, it's not like that.
I know.
You need a game like Counter-Strike, and then have a deep network with a lot more processing power that anyone currently is willing to give it, and a structure that has not been developed or researched yet, and have it play like million games to be at some level.
There is like a rumor that I heard about something like that. Like there was like a rumor about a either Doom or Quake, but someone had run a bot match with a deep learning software running all the bots. Only ran it for like a year or two. It's probably, but I think that the message was kind of interesting. After a while, eventually they all stood still and realized that in order to get the perfect kill-death ratio was to just not be killed or...
Let's go to the next one.
Okay, sure, cool. I just thought that was an interesting story. How can I stop a behavior tree to wait for an action to complete? Wait? I mean, or we can...
What kind of action? I mean, you can pause logic. Yeah. There's a pause logic function on the brain component. But in general, if you have a blueprint implemented BT task, just don't call finish execute. Just wait for the action to finish before calling finish execute. Because as soon as you call finish execute, it will return the control over to the BT component that will find another action to perform. I'm guessing that's the question.
I mean, maybe.
Yeah. The selector.
Okay. I'm going to mark that one off then. Cool.
No, wait. We didn't answer this one.
No, we did okay, whoops.
Yeah, it's like left from left to right. Left is the highest priority.
In the selector, which...
And that's both in the sequence
which sequence has precedence, and it's left to right. It's left to right. And actually, hang on, I'm going to open it up again. If you look really carefully, these little numbers over here actually tell you. They tell you in what order things should execute if everything goes well. So it says like 0, 1, 2, and if things go well, 3, 4, 5. Yeah. But if not, it'll skip over here, and then you can see them highlight when you.
So-called execution index.
Yeah. So you can actually see what order they will execute in. Even if you're just unsure, you made something really complicated, you can just look at those numbers to help you out. Yes, the same question again. Basically, will there be an advanced AI stream in the future, preferably C++ stuff? I am not a...
I mean, we could do that, but it's we would need a like something to focus on.
Yeah, and actually, if you want to see more C++ stuff with some basic AI stuff in it, you'll want to check out the Tanks versus Zombies streams that Lauren and Richard do. They're going to probably pick them up again after GDC is over, but they've been building some zombies with C++ AI in them. It's pretty simple AI, but it'll get you running, gets you up and started. Why, when I get nav polys in C++, do they not include outside/border edges of the nav mesh?
Not sure what you mean. When you ask for polys, you get polys. That's why you're not getting edges.
I don't know.
Because a polygon has edges around
I
it,
have
but
a
an
feeling
edge
there's
is not a
more
polygon.
story to this one than we're getting. So
Yeah,
feel free to go to the forums.
Yes.
Go to our forums in the events section, find this event, ask it there, and I'll see what we can find about that one. All right, we're getting. Yeah, I'm gonna probably do. Oh my gosh. Okay, we're getting a ton of questions. I'm gonna do one more and then.
Why? I mean, I'm fine.
Okay, you okay?
I have
Okay, then
time.
never mind. Okay.
It's on the house.
Oh wow, thank you. My goodness, this is great.
Not my house. This house.
No, yeah, well, it's on Tim. Then is what you're getting at.
Yes.
Yeah, it's on Sweeney. Thank you.
Thank
you, Tim.
Thank Tim.
Okay, I'm sorry. I got you. When a decorator has hit observer aborts set to anything other than none, how often does it check for a changed value? It doesn't.
That's the magic. It doesn't check for the value. It gets notified by the Blackboard when something changes.
Okay.
So it's as efficient as possible.
All right. Cool. AI debugger seems to not run its updates too often. Is there a place to up the rate of how often it updates? My graphs are looking
No, it
chunky.
updates all the time.
Okay.
Well, AI debugger, you mean behavior tree debugger, or?
I assume he means like when you hit the apostrophe and the AI debugger all shows up and then.
So it, if you work in a client server environment, it needs to replicate the information from the server, and sometimes, depending, it's a low priority information stream. So if there's a lot of stuff going on in the network, it can take a couple of seconds before all the required information gets replicated. And then refresh rate also depends on the network traffic. And it might actually influence the local debugging as well. So there's that.
All right, cool. Yeah, we are getting really late though, so I'm gonna try to knock out.
Not yet. The answer is
no. Come on, just okay. Did you
for the question you're gonna read.
did you manage to fix the AIPerception affiliation flags not displaying properly from C++ yet? And then whoever it is says that they hide. So it's probably
Right,
Luos. Yeah. I'm trying to think of who likes to do that, where they ask a question and run away. Zumba. Okay, yeah, he's messing with you.
If he's there.
So
He likes to mess with me, that's for sure.
So the answer is working on it then.
Yeah, it's on the to-do list, and it's higher, closer to the top than the bottom.
Okay. So. How do I set up an AI that loses track of a player out of sight without being too dumb? Actually, that's in Perception. You can have them forget their location.
Yeah,
right?
there's it's something I fixed.
Yeah, if I go into this AIPerception. AIPerception over here, we have max age, and max age is how long he will remember that last place he saw you. So that's it. Just set this to 0 for he never forgets, or set it to 5 for 5 seconds, 10 seconds, etc. It's in seconds. That's it. We've got quite a few other questions, more coming in rapidly. We're getting close to 2 hours, and I've got meetings, and I think Clint does too. He's giving me the evil eye. What we'll have to do is probably have a follow-up stream and just do like a big Q&A stream with just you, because look at all these questions.
Sure, I don't mind.
And actually, that was a thing that I had initially hoped we could do today. Was a lot of Q&A, but I went over quite a bit trying to get these done. I don't know why I would possibly go over if we were staying on script. Maybe it would.
Yeah, no one was bothering you, right?
No, not at all. But yeah, Clint.
Sure, yeah.
Jumping
Let's
back over
organize
here to
another one.
us.
Keep the list because there's some interesting questions there.
Yeah,
as
there's
well.
really great questions. What I'm going to do is I'm going to take these questions and I'm going to go over to the forums and we're going to try to work our way through as many of them as possible. If it's cool with you, thank you for your time.
No problem.
But for right now, I've got to do the outro and get everybody back to work. So
how do you do an outro? Outro, bye.
No, outro. So join us again on Thursday.
Oh, yeah, right.
Yeah. We
Stuff
do this
like
all the time. So on Thursday at 2 p.m. Eastern Standard Time. Eastern. Are we on Eastern Time? Whichever one we're on right now. Daylight's standard, one of the two.
It's standard. Standard.
Standard is okay. So at 2 p.m. on Thursday, we're going to be having yet another awesome stream. As we always do, Tuesdays and Thursdays, we have these unrealized streams. I'm going to bring on a guest. We're going to talk about something cool. This Thursday, I've just gotten word from Aaron McLaren, who has an amazing name. If you guys haven't heard of Aaron McLaren yet, he does the audio stuff and took over from Mark Audie, who was Mark Audie on audio. You cannot write this. I know. Clint's giving me a look like, no, seriously, the guy who did audio was Audie, and now we have Aaron McLaren, who's doing audio. And yeah, they're all cars, yeah. And so yeah, I'm gonna work out that with him, and we'll have a post up soon to give you more details on that. So come on by on Thursday. It'll be a great time. You making fun of me, and we'll have him come on and make fun of my hand gestures and all the silly things that I do again. But that's what I got. Thank you so much, Mieszko, for coming on. Yeah,
we'll being here.
Yeah, we'll see you all next time.
Yeah.
Later.
See ya.